Hello, I'm Mrs. Stevenson. Resistance and current in a parallel circuit. Three resistors, 60 ohms, 30 ohms, and 20 ohms, are connected in parallel across a 90-volt battery. A. Find the current through each branch of the circuit. B. Find the equivalent resistance of the circuit. And C. Find the current through the battery. If we look at our diagram, this symbol over here represents our 90-volt battery. This is the positive side of the battery, and this is the negative side of the battery. These symbols A represent ammeters, which should be connected in series in the circuit. The zigzags represent the resistors, and they each have different resistances. And because this is a parallel circuit, the voltage is the same across each resistor. So the voltage across each resistor will be 90 volts. As the current passes through the parallel circuit, it splits. So the current travels through the wire. Some of it goes this way, some of it goes this way, and some of it goes this way. And that's what we're trying to figure out in Part A. In order to do this, we want to list our knowns and unknowns. Our knowns are that for resistor A, it is 60 ohms. 60 ohms. Resistor B is 30 ohms. Resistor C is 20 ohms. And the total voltage is 90 volts. Our unknowns we are looking for the current across resistor A, the current across resistor B, the current across resistor C, the total current, and the total resistance of the circuit. We're going to be using Ohm's law to solve these problems. Ohm's law is the voltage is equal to the current times the resistance. But for Part A, we are looking for current, so we want to get current by itself. We have to then divide both sides of the equation by the resistance, so it cancels on the right. So we see that current is equal to voltage divided by resistance. This is true for the whole circuit, and this is true across each resistor. So if we want to know the current across resistor A, we're going to take the voltage across resistor A divided by the resistance of resistor A. Because this is a parallel circuit, the voltage is the same across each resistor as it is the total, so we have 90 volts. And the resistance of resistor A was 60 ohms. So we find that the current across resistor A is 1.50 amps, because amps is the unit for current. I'm going to repeat the same procedure across the other two resistors. So the current across resistor B is equal to the voltage across resistor B divided by resistor B. So again, we have our 90 volts. And resistor B was 30 ohms. So we find the current across resistor B is 3 amps. Amps representing current. Lastly, to find the current across resistor C, we need to take the voltage across resistor C divided by the resistance of resistor C. Once again, our voltage is 90 volts. And the resistance of resistor C is 20 ohms. So we find that our current across resistor C is 4.50 amps. We found all the individual currents across each individual resistor, And next we want to try and find the total resistance or the equivalent resistance for this parallel circuit. For parallel circuits, to find equivalent resistance, you have to use the formula 1 over the equivalent resistance is equal to 1 over the resistance of resistor A plus 1 over the resistance of resistor B plus 1 over the resistance of resistor C. We're looking for the equivalent resistance, which is here, and we have known values for each of these. So we're going to have 1 over the equivalent resistance is equal to 1 over 60 ohms plus 1 over 30 ohms plus 1 over 20 ohms. We find when we add up all of our fractions, we find that 1 over our equivalent resistance is 1 over 10 ohms. And if we flip or take the reciprocal of each side, we see that the equivalent resistance is equal to 10 ohms. This is the total resistance of the parallel circuit. Lastly, we want to find the total current of the parallel circuit. And once again, we're going to use Ohm's law, which we rearranged to solve for current, where the total current is equal to the total voltage divided by the total resistance. We knew from the beginning that our total voltage was 90 volts, and we just found that our total resistance was 10 ohms. So we find that our total current is 9 amps. And a good way to check yourself to make sure that this final answer is correct is to go back and look at your individual currents. We had current across resistor A as 1.5 amps. The current across resistor B as 3 amps. And the current across resistor C as 4.5 amps. If we add up our individual currents, 1.50 plus 3.00 plus 4.50, you see that we get 9 amps. So both ways you solve this problem, we get the same answer of the total current being 9 amps.